Good morning, students. In this video, I shall discuss the monohybrid test cross. Now, question is, what is this test cross and why this test cross was used by Mendel? Now, when we observed in the monohybrid cross experiment, monohybrid cross in the F2 generation. In F2 generation, there are two types of genotypes, T, capital T, and capital T, small t. So, two types of genotypes were there, but when we observe from the outside, the phenotype is tall here and it is also tall. So, from outside or from external appearance, how can we know whether it is a homozygous tall or it is a dominant tall or it is an heterozygous tall or hybrid tall? So to test whether the tall plant of F2 generation is either homozygous tall or heterozygous tall. So to identify it, to test the type of genotype, we actually use this cross. Now what is this test cross? Test cross, it is a type of back cross. It is a type of back cross. Now what is a back cross? The back cross means when the F1 hybrid is crossed with either of the parent, either dominant parent or recessive parent, then it is called a back cross. Because the F1 hybrid, it is the second generation F1 hybrid, when it cross with the P1 type. So P1 type either it is dominant or recessive, then it is called the back cross. Now how this back cross is done here? Suppose we can take the example of this tallness and the shortness character. Suppose it is F1 hybrid is capital T small t. Now when it is crossed with either capital T, it is the homozygous dominant parent, it is the P1 generation and it is F1 hybrid. Now what is the result here? Look at the result. Now first one. Now suppose this is the female one and we take the male one. There are two types of gametes will be formed here. It is the capital T and small t, and here capital T and capital T. Then the offspring or the next generation product are capital T, here also capital T and capital T small t and capital T small t. Now here this is no doubt a back cross, but this back cross, it actually does not solve our problem or solve the problem of the Mendel, because here all are tall. All are phenotypically tall. So when all are phenotypically tall, then how can we identify it is whether heterozygous or homozygous tall? So that is why it cannot actually solve the problem. But when he crossed the F1 hybrid, that is capital T small t, and it is the F1 generation. Now when it crossed with the parental type or parental recessive type, now small t. Now here what happened? Now look at the gametes formed here. Suppose this is the male one, this is the female one. Then two types of gametes will be formed here, the capital T and small t here, and here the small t and small t. Now when this pollen grain or this gamete will fertilize this gamete, then it will be a capital T small t. And when this one also capital T small t. And but here, look at here, this is small t. So that means in the first row, they are all tall one. These are the tall plant. And in the second row, these are the dwarf plant. That means here the tall is to dwarf, tall is to dwarf is equal to 1:1. So this ratio, this ratio is one of the important ratio by which one can, or the Mendel actually identified the genotype of the dominant phenotype of F1 hybrid. So here, from this cross, if the ratio of the F1 hybrid or F1 generation, or you can say any dominant phenotypic character with the double recessive parent, then if the ratio is 1:1, then the genotype will be a heterozygous one. So that is why this test indicates that it is the heterozygous parent. But here, if it is with the dominant parent, then it is all are tall. So that is why it does not solve the problem. That is why this cross, it called the test cross. Now look at here. This cross is called the test cross. Now, how can we define this test cross now? When any of the unknown dominant parent or dominant type of organism or plant, you can say, when they cross with the homozygous recessive parent, then if the ratio will be 1:1, then the unknown genotype is your heterozygous type. Now, when the unknown dominant organism, you can say, or plant, you can say, cross with homozygous recessive parent, homozygous recessive organism, then if the ratio of dominant is to recessive is 1:1, then the unknown dominant organism is heterozygous type. It is heterozygous type. So it indicates that it is a heterozygous type. And if it is not, then automatically it is homozygous. Suppose it is homozygous one, and when we cross it with the small t, then what will happen? It will all are, look at here the T and another is also T, and here all are T, then here it will be the same, all are tall. So that is why it, so when it is heterozygous, then only we will find 1:1 ratio. So that is why this 1:1 ratio is found when the unknown genotype of a dominant phenotype. The phenotype is not a dominant one, suppose it is tall, but whether it is a homozygous tall or heterozygous tall, it is not known. So that is why Mendel used this cross to identify the dominant one, whether it is homozygous or heterozygous. If it is really useful for you, then please like it and subscribe for further videos. Thank you.